Academic, Monday, May 8th. Continue with the 9-4 notes, okay? We're going back to sequences, okay? All right, so for arithmetic sequences, that's a list of numbers where you get each number in the sequence by adding the same number each time. Okay, it's called the common difference. So 5, 7, 9, right? We add 2 each time. The formula for the nth term is given by this. That's the recursive definition. So that means if you want to get a term, you have to know the previous term. Another definition for how to get the nth term is a sub n equals the first term plus n minus 1 times d. That's probably a better formula for you to use. Okay, so to get the nth term, I take the first term and I add the common difference to it n minus 1 times, right? So to get like the 50th term, I take the first term and add the common difference 49 times. Right here, we should do a sub n equals a sub 1 times r raised to the n minus 1. Okay, so if you want to get the nth term of a geometric sequence, like let's say I wanted to get the 50th term, right? I would take the first term and instead of adding the common difference every time, I would multiply by the common ratio 49 times. Does that make sense?
Can you go back?
Between a geometric sequence and an arithmetic sequence, or between the yellow and the pink one?
Yellow.
Yeah. So this just means the nth term equals the previous term times r. Okay. These are both two formulas you can use to get the same thing. They just take different inputs. For this one, to get the nth term, like to get the 50th term, you would need the 49th term. For this one, to get the 50th term, you just need to know the first term and the common ratio. A lot of times, it's easier to get the first. It's easier to get the first term in a sequence than it is like the 49th or whatever. Okay. So this is what's called an explicit formula. Explicit. This is what's called recursive. So explicit. Okay, so let's consider these following sequences. Tell what type they are, give an explicit formula, give a recursive formula. What are we thinking for this one? What kind? Is this arithmetic or geometric? What kind of sequence is this? Why are we thinking arithmetic? Because you're adding 4 each time. You're adding the same thing each time, okay? Let's do an explicit formula. Well, let's do an explicit formula, okay? So explicit formula is this guy right here. So this is the first term. What's my first term here? What's the first term in this sequence? 3. And then plus n minus 1. What's the common difference? There we go. That's the explicit formula. Okay. The recursive is just the previous term plus that 4. Questions, comments, concerns? Sorry. Going to school, I thought they would have the heat on still. All right, can I go into part B? So how do they get from -2 to 1? How are they getting from these numbers? What are they doing? What are they multiplying by? So they're multiplying by something every time, right? So it's going to be geometric, right? Right. This is not a common difference, right? The difference between -2 and 1, that's 3. That's not the same as the difference between these numbers, right? That's 1.5. So it can't be arithmetic. It has to be geometric. Okay. What did they multiply by to get from -2 to 1? -2 times x equals 1. What's x equal to? -1/2. Okay, so my r is -1/2. What that means then is to get each new term in the series or in the sequence, you multiply by -1/2. Okay. So an explicit formula is, let's look at this. The first term times r to the n minus 1. So what's my a sub 1 here? What's my first term? What's the first term in this sequence? -2, then times -1/2 to the n minus 1. That's an explicit formula. The recursive formula is just the previous term times that common ratio. So to get a formula for every single term in the sequence, you just need to know the first term and then either the common ratio, if it's a geometric sequence, that's the number you multiply by to get each number, or the common difference, which is for an arithmetic sequence, the number you add each time to get each new number in the sequence. Are we following or are we lost? We're lost. Well, that's too bad. We got to move on. Okay. So they asked me to tell what type of series this sequence this is. Are we following that? It's arithmetic, and that's because you're adding the same number each time to go from one term to the next. Okay. So it's arithmetic, so we're going to use the recursive and explicit formulas for arithmetic sequences, given right here, okay? So an explicit formula for an arithmetic sequence, we just write this down, we just copy this down, okay? And then we just write in what the first term in the sequence is, and then D is the number that I'm adding each time to go from one term to the next. So to get an explicit formula for this sequence, I wrote down the a sub 1 plus n minus 1d. Okay. Get an explicit formula. Okay, I wrote down what the first term is. Right here, I just copied down 3. And then the number that I add each time to go from one term to the next is 4, right? 3 plus 4 equals 7. 7 plus 4 equals 11. 11 plus 4 equals 15. So I just copied 4 right here. So that's so if I ask you, hey, give me the 9,000th term of this sequence, of the sequence right here, all you would have to do is just plug in 9,000 for n. Okay, that's what's nice about that. The recursive formula is just, it's always going to be a sub n equals a sub n minus 1. You just always copy that down, and then plus that number, the common difference. Okay. So this you always write down, this you always write down, this, and n minus 1. You're just plugging in numbers for a sub 1 and d, and then down here in my recursive formula, you're plugging in a number for d.
So you always have to do both?
I usually will do mostly just explicit. Yeah. Recursive's not as useful if you're a human. If you're a computer, it's good. So you're an NPC, get out. Writing in fraction. This student is not actually a human, they are a cyborg. I'm convinced. Same, so here it's a similar process. We're just multiplying by the same thing. Instead of adding the same thing each time to get from one term to the next, you're multiplying. Right? -2 times -1/2 is 1. 1 times -1/2 is -1/2. -1/2 times -1/2 is 1/4, and so on. Okay. All right, I'm going to move on. I'm going to skip the Fibonacci sequence stuff. be on, I don't want to put it on the test. Fibonacci sequence, it's a special type of sequence. To define it, you need to know the first two terms, okay? And then each term is just the sum of the previous two. Okay? So 0, 3, what the heck? I don't know what's going on here, to be honest. That's not a Fibonacci
Oh,
sequence.
you're a computer.
What? I'm not a computer. Stop.
Why would it lie to you?
What?
Why would it lie to you?
Maybe you're programmed. Yeah, we're just going to skip this. Looks like this might be that whole page. All right, so let's find the first three terms and the 50th term of these two. Okay, so a sub 1, to find the first term, I call that a sub 1. I just do what? Yeah, just plug in a number. Just plug in 1 for n. So it's 1 plus 1 over 1, which is 2. A sub 2 is 2 plus 1 over 2, which is 3 halves. A sub 3 is 3 plus 1 over 3, which is 4 thirds. So those are the first three terms. The 50th term is 50. So a sub 50 equals 50 plus 1 over 50, which is 51 over 50. Questions on that? I'm just plugging in the number at the term. Okay. A sub n equals 4 over n plus 2. My first term, 4 over 1 plus 2. Second term, 4 over 2 plus 2. Third term, 4 over 3 plus 2. 50th term, over 52. Okay.
Do we have to simplify that?
4 over 52?
Yeah.
Sure. That's 1 over 13. Okay, now we're going to talk about whether a sequence diverges or converges, okay? All right, so a convergent sequence means like the terms get closer and closer to the same number. They get closer and closer to a number as n increases. Okay, that's the layman's definition. Okay. The more rigorous definition, if you want to come get that, that's an office hours question. Okay, I can give that to you. But yeah. Okay, so the terms get closer and closer to the same number. Okay, does that make sense? It doesn't make sense? It's okay if it doesn't make sense. Okay. So this one right here, yeah, this one's convergent. This one right here, we're getting closer and closer to 0 each time. Okay, 4 over 52, that's a pretty small fraction, right? What if we found the 1000th term? The 1000th term would be 4 over 1000 plus 2. That's a really small fraction, right? What if we found the billionth term? It'd be 4 over 1 billion plus 2. That's really, really, really small fraction, right? So our terms are getting closer and closer to 0, which means it's convergent. Does that make sense? It's getting closer and closer to the same number. Divergent means it's not convergent. Not convergent. It diverges. You guys ever read the book Divergent? No? Come on. That was so fun. Like in pre-cal, I remember being like, Divergent. It's Divergent. No one's read Divergent?
I read it.
It's a children's novel. Is it a children's novel?
I don't think Daniel's read it.
I read it.
He's a cyborg. He's read everything. Hey, ChatGPT, give me a summary.
I mean, it's alright.
Yeah, I read it.
Divergent is an American novel about
Did you hear NBC?
NBC Watch.
Did we get a calculator on that?
Yeah. Okay, so right here, is this sequent convergent or divergent? Is it convergent or divergent?
Or divergent.
Why do you think it's divergent?
Sure, it's always going up.
Let's ask ourselves, is there a number that they're always getting closer and closer to? No, so it's divergent. Goes to infinity. Ooh, what about this one? Is this one convergent or divergent? Why do you think it's convergent?
It's close to 0.
What's it going to get closer and closer to? 0. Converges to 0. Okay, are we okay with that? This is like a really hard topic, actually. This is a really hard concept, so if you guys are getting it. Converges to 0. Okay. Ooh, look at this one. Look at this one.
Divergent.
Think it's divergent?
You have to plug it in.
Oh, you can. Let's say the first term is going to be what? 3 minus 1 over 1 plus 2, so 2/3. Second term is going to be 6 minus 1, so 5 over 4. Next one's going to be, I'm pretty sure this converges. 9 minus 1 is 8. The third term, 5, 8/5. What I'm asking myself right here, do you guys remember when we did like the rational function stuff? Like the limits at infinity, the end behavior asymptotes? You guys remember that? We compared like the degrees here. So I'm thinking about what happens when I'm asking myself, what happens as n goes to infinity? What happens as n goes to infinity? Okay. So do you remember what's the degree of the top? 1. That's the lead coefficient is 3. What's the degree of the bottom? 1. The top and bottom have the same degree, so how do we find the end behavior asymptotes? Do you guys remember, you divide the lead coefficients? Do you guys remember that? So 3 divided, I'm pretty sure it converges to 3. Converges to 3. The same one, I think, will converge to -2. I can actually check. We can actually check our work. Let's just plug a billion into these. So for C, let's plug a billion in for n. So 3 times 1 billion minus 1. Store that as A. Let's do a billion plus 2. Store that as B. A divided by B is 2.99999999993. Okay. So I guess you guys see what I'm doing there to check my work?
Yeah.
Just plug in another strategy, let's write this in the margin. Another strategy is to plug in a billion for n. If you suspect it's convergent, right? If I were to plug in a billion into 1, I'd probably get a number really close to 3 as well. Okay. This one's going to converge to -2 then. All right. This one, we know how to do this. What does this converge to? What's this equal to? 4/5. Yep. Again, that's because the degree of the top and the degree of the bottom are the same. Okay. This one, what's going on here for F? What's going on? What's the degree of the top? What's the degree of the bottom? So the bottom has a greater degree, right? Does anyone remember what the limit at infinity is if the degree of the bottom's greater? 0. Right? A billion over a billion squared is a really small number. Okay, a trillion over a trillion squared is even smaller. Okay? That makes sense?
So this is a conversion?
This is convergence. Yeah, these are both convergence. They only gave us one example of a divergent. Yeah. It's a little sus. All right, G, the limit as n goes to infinity. What's going to happen here? What's the case here now? Is the degree or top? Is the bottom or top degree greater?
Top.
Do you remember what degree is?
Top.
You're good. Top. So when the degree of the top is greater, what happens is it's divergent. We're just going to say this diverges, okay? This is a DNE. Does not exist. The limit does not exist. The limit does not exist. Good. It's just people who are like going to live near Evanston next year, like we like kind of get the Mean Girls vibe.
You're like so Chicago.
I'm like so Chicago. Honestly, like Wrigleyville, I like moved on from that. Just like so like overrated.
What is it?
Northwestern?
Yes.
Yeah, not since I committed, but I visited. I'm 100% committed.
You guys.
I love to go out I love to hang out with friends. Try new
Is
restaurants.
anybody here going to?
No. One of my best friends from seminary is going to be there next year. All right. What about here? Limit as n goes to infinity. Okay.
Conversion.
Why do you think it's convergent?
Because it's less than 1, so it's going to...
Okay, yeah, so he's on the right track. So this is a geometric series, right? 2/3. Let's write out some terms in this, okay? The first term is 2/3. Second term is 4/9. Then it's 8/27. So is anyone having trouble seeing that this is a geometric sequence? What are we multiplying by each time? What's my R here? What's my common ratio? What's the number I'm multiplying by each time to go from term to term? 2/3, right? R equals 2/3, so it's convergent, okay? Okay. So write this down. This is a little note, okay? In a geometric series, okay, if R is between -1 and 1 exclusive, then it converges. Otherwise, not. Otherwise, no. Okay. If R is between -1 and 1 exclusive, so it can't be -1, it can't be equal to 1, then it converges. This is a geometric series, right? You're just multiplying by 3/2 every time. Does this diverge or converge? Diverge. Why does it diverge? That common ratio, right? That number you're multiplying by each time is greater than 1. Same thing here. Is this convergent or divergent? Don't let them throw you off. That doesn't matter. That doesn't even matter. That -3 is irrelevant. The -3 is irrelevant. It's mid. So this is a DNE. Does not exist. Or you can write divergent or does not exist. Don't write that it equals infinity. That's a pet peeve of mine. A number can't equal infinity. Infinity is an adjective. It's not a number. What's that? There's a symbol, yeah. But like there's a symbol for purple. Like just write purple. Like, what?
It's like writing out infinity.
Like if
It's like writing out
use the
infinity.
letter.
Do you not like the symbol infinity at all? Like.
No, I don't mind the symbol, but like I don't like writing that when people say like this equals infinity. I don't like that. Because infinity is it's not a number, it's an adjective. It means without end. So like saying like this limit equals infinity is like saying it equals purple. Like it's just meaningless. I just write DNE or divergent, please. Plus DNE is a Mean Girls reference, so. The limit does not exist. The limit does not exist.
Oh.
You're a great guy.
Yeah, I don't watch movies.
I love Mean Girls. Aaron Samuels. Aaron Samuels went to my school.
So bad. What?
Aaron Samuels went to my school. He went to Northwestern. What? I know, I can't get over it. Maybe I'll see him. On the way to prom, I was texting my sister, and I was like, I wonder who's going to win Spring Fling Queen.
Did you have any predictions?
No, I didn't. Okay, I do have a prediction about this. Is this convergent or divergent?
Convergent.
Why do we think it's convergent?
Because the R is in between negative.
So what we're doing to get from each term to get from term to term, what we're doing is we're just multiplying by 0.36 to the fourth. 0.36 to the fourth is much less than 1, so it's convergent. Are you guys doing okay with this? This is like the hardest thing in math. This is like one of the hardest things.
Really?
Can you go over that one again?
This one?
Yeah.
So let's talk about this. The first term, let's plug in 1 to get the first term. The first term is going to be 0.36 to the fourth. Okay? Second term, if you plug in a 2 instead, it's going to be 0.36 to the 8th. And then if you plug in 3, you'll get 0.36 to the 12th. So all you're doing to hop from term to term here is you're multiplying by 0.36 to the fourth. Right? You're adding 4 to the exponent each time. You see that?
Yeah.
So what we're doing here to go remember when you add it when you multiply two numbers together, right? I'll use x. If I did x to the fourth times x to the fourth, that gives me what? X to the 8th, right? Or x to the 8th times x to the 4th. That gives me x to the 12th, okay? So we're adding 4 to the exponent each time, which means that we're multiplying by that number to the 4th. Does that make sense? 0.36 to the 4th is way less than 1, so it's convergent. It converges. 1.5. What are we thinking for this one?
Divergent.
Why are we thinking divergent?
It's greater than 1 is geometric size.
So what's going on here? The first term is 1.5 to the 1 over 2. The second term is 1.5 to the 2 over 2. Then it's 1.5 to the 3 over 2. So we're multiplying by what each time to go from term to term? We're multiplying by 1.5 to the 1/2. What's the square root of 1.5? 1.2. So it's divergent. D and E. Does not exist. Or you can say divergent. It's my favorite. There's a proof on the internet that the sum of all natural numbers equals -1/12. It's like 1 plus 2 plus 3 plus 4 plus 5 plus 6 on to infinity. There's a proof. There's actually multiple proofs that equals -1/12. So it's kind of controversial. That like 1 plus 2 plus 3 plus 4 plus 5 plus 6, if you add them all up, every number, it equals -1/12. I don't know. My thesis advisor disagreed with it. He disagreed with it. He was like, "This is terrible. It's like corrupting kids." I also disagree with it. Anyway, how are we feeling about this? Can I keep going? Okay. Find the first 5 terms. This one's just kind of plug and chug. So what this is saying, to go from what this means right here, a sub n plus 1 equals a sub n. This is just to get the next term, to get the next term in the sequence. We take the previous term, we multiply it by 2, and then we subtract 5. Okay? So how would I get a sub 2 here? I would do what? I would do, on my calculator, 3 times 2 minus 5. 1. Okay? To get a sub 3, on my calculator, I would literally just hit times 2 minus 5. That gives me -3. So I'm just doing times 2 minus 5 each time. Times 2 minus 5. plugging in. I first start by plugging in 3. I plug 3 into this formula right here, and then I plug in a 1, and then I plug in the next. So I'm just going. I plug in the next one, whichever one I got. So I'm just going down the list. Does that make sense, Kate? Okay. Aaron Samuels. Alright. Can I do the next one? Okay, thank you. Thank you, Daniel. ChatGPT, can I do the next problem? I want to watch Mean Girls, okay. So with this, what's happening here is, to get the next term in the sequence here, I have to take the previous 2 terms and multiply them together. Okay? So they give me the first 2 terms here. What's my next term going to be? What's a sub 3 going to be?
Plug in 4,
No. What's a sub 3 going to be?
5.
12.
Alright, can you explain that?
So what this is saying, to get each subsequent term in the sequence, I take the previous 2 terms and multiply them together.
Oh.
So to get 12, I just multiplied 3 and 4 together. What 2 numbers am I going to multiply together to get the 4th term?
12.
Yeah, now give me 48.
That one's like
What?
the
No, Fibonacci, that's like you add them. And then what 2 numbers am I going to multiply together to get this 5th term here? The 12 and 48. Does that make sense? Okay. 12 times 48 is 576.
Wait, so for the last one, it was
A or B?
A.
So I took this 3, this one was equal to 2 times 3 minus 5. This was equal to 2 times 1 minus 5. So each time, to get each new term here, I'm just taking the previous one and multiplying it by 2 and subtracting 5.
Oh, so you're plugging it in.
I'm just plugging in the previous term, yeah. Does that make sense? It's recursive, okay? So to get the 1,000th term, you'd have to do times 2 minus 5 1,000 times, which stinks. Unless you're a computer, they can do it really fast. ChatGPT, find 1,000th term.
What?
You're a cyborg, find 1,000th term. Be hilarious. We heard you started a rumor that one of your students doesn't exist.
Shut your name and skip the front.
Are you guys feeling good about B? Sorry, I'm trying to talk slowly.
You plug in these two, and then you plug in these two.
Yeah, so I multiply these 2, give me 12. Multiply these 2, give me 14. Yeah, you're using the
How
numbers.
do you know you're like multiplying?
It says a sub n plus 2 equals a sub n plus 1 times a sub n. So,
But you don't do it plus one. Why aren't you doing it plus one?
like right here.
Yeah.
Oh, that plus 1 right there is part of the subscript. It's just like a label.
That's why I was so confused.
Sorry.
I was like,
No, yeah, these are labels. This is like a name for that variable. That's just naming your variable.
so you just
So like if I named you like k plus 1 like a birth certificate, right? That wouldn't be like add 1 to k. It'd be like this k. Yeah.
because that would just mean those
What's the
numbers are
last
the same,
term
but
that
then
one?
you just would be four.
Okay.
Like,
No, you're not adding a 1. That's just a name. That's just a
I
name.
don't like
Sorry.
that. But it's like a plus.
Subscripts. You don't like subscripts?
You should just put like a one on it.
Subscripts are just a name. Subscripts are just a name. Ignore them. They're just a name. Subscripts are just a name. Mathematicians love them. Really? Shit, that's awesome. this next one, okay? So the first term is 4. What the first term is 4, okay? And what my rule says, what my formula says, is to get the next term, you take the previous term, you times it by 3 and add 2. So I'm going to take my 4 and I'm going to times it by 3. What's 4 times 3? And then add 2 to that. What do I get? 14. Okay? So now to get the next term, I'm going to take my 14, I'm going to times it by 3. What's that? Plus 2 gives me 44. Okay? Then to get the next term, I take my 44, I multiply it by 3, and I can add my 2. So what's 44 times 3? And then plus 2, I got 134. Okay, then to get my next term, I take my 134, I times it by 3 and add 2. Any questions? Any questions, comments, concerns? All right, let's go on to the next part. Oh no, I'm at 1%. Most people don't know I'm actually a parkour hunter. Parkour there. So actually, please don't parkour there.
Can I work more than that?
No. You guys remember the hardcore parkour video from college? This is like back in the day. This is my brother's senior year of high school. Like some kids are on Collie. They had like a sub. Like the teacher was coming. So we filmed the video. We're like they're sitting in class, and like they're all sitting there, and then the kid just goes. Every kid in the class got on top of the desk and started like moving from desk to desk. And the Archbishop's all the video suspended, like all the kids in the class. Anyway, alright, anyone know what kind of sequence this is? So how are we getting between numbers? How do we go from 3 to -1? What did they do? Did they multiply by -1/3 or did they subtract 4?
Subtract 4.
How do you know they subtracted 4?
Because I'm ChatGPT.
Okay, someone other than ChatGPT, how do you know they subtracted 4? Yeah, so to go from -1 to -5, they did the exact same thing, right? So just to check our understanding, what would the next term of the sequence be?
-13.
-13, okay. So we know the common difference, that's what? -4. And then what's my first term here? 3. If I have these two things, I just plug those into the formula to get the formula for the whole sequence. So the nth term of this sequence is going to be the first term plus n minus 1 times that common difference. Okay, you just plug that in. So that's part of my answer then. And then what's my 8th term going to be? How do I use this formula to get the 8th term? Plug it in. So a sub 8 equals 3 plus 8 minus 1 times -4, which is what? 3 plus 7 times -4, which is 3 plus -28, which is -25. Common difference is -4. An explicit rule for the nth term is this. And then plug in 8 to get the 8th term. Questions on how I did that? So I guess I feel like I didn't explain this that well. In general, for any arithmetic sequence, the rule to get the nth term is a sub n equals a sub 1, the first term, the nth term equals the first term plus n minus 1 times d. So what I did here is I just found the first term, a sub 1, and I found my d, and I just plugged them in. Okay, are we okay? Okay. Want to make sure we're understanding that. Okay. All right. This next one. How did we go from term to term? How did we go from 3 to 6 and 6 to 12? Times 2. Okay. So this is geometric, right? So my r is 2. It's geometric. Okay. I'm going to do the exact same thing as I did for my arithmetic sequence. But there's just a different formula. This one, the rule is a sub 1 equals, or a sub n equals a sub 1 times r n minus 1. Okay, so what's my a sub 1 here? What's the first term? And what's my r? There you go. So that's an explicit formula for every single term in the sequence. Okay? So what would the eighth term be? How do I get that? Plug an A. 2 to the 7th is 5 or 12, right? That's 15. Is that 1536? I love my abacus. Couple minutes left. We're a little behind, so let's go ahead. Let's do it. I'm going to give you guys a video for tonight. It should be like 10 minutes just to finish 9.4 and then do the 9.4. Okay? Is that okay about that?
We don't have the, do you want to just do it on sports? We don't have the.
You don't have the, oh shoot, let me pass that out. I'm sorry. Alright, everybody take a homework on your way out. Actually, let's pass it out real quick. I couldn't find a keyboard. Let me.
I'd like to just do the homework during the video too.
Apparently, senior night starts at 4:30, so kind of early.
Yeah, it is early. Normally it's at like 5.
Are you manager?
No, I just play tennis.
So let's watch that video and make a little 15-minute. Thank you guys. Take one pass back. Take one pass back. No, I gave you 3. Okay, next.
You got it.
Aaron just took 3. Going.
There you go.
Thank you, Alan. Got him. Yeah, you take care.
Nervous for your AP Cal kids?
Yeah, a little bit actually. I didn't email them. I feel like I don't need, should I remind them to
Did you?
recalculate?
I feel like they should be smart enough to
I
maybe
know.
email them and be like, hope you all good luck.
They weren't trying to learn it. They were like 2 kids trying to learn it.
That's fair though. Most of them probably can like.
Check it out. If I taught AP again, I'd just review as the year went on. Yeah, what should we do?
Probably not.
If they didn't try this, they weren't. have one thing of notes. Wait, this is our last notes of the whole year.
Are you really?
Oh, no!
We have homework.
Yeah, we had homework. Number 43, the review worksheets. No, do you want a quiz?
What?
I get one of those.
I don't even I thought I had it.
Center's 402. But for next, 320 to the line.
What?
For that parking lot through field.
My hands are pale. The spray tan.
Oh no, I forgot to stop recording.